Welcome everyone to this series of videos on the subject metal cutting and machining principles. This is the second part, and in this video I am going to share a simple way to remember all the 6 different angles in a sequenced manner as proposed by the ASA tool signature system. So let's see what is a tool signature. The process of enlisting 6 different inclination angle and the nose radius in a predefined manner is known as tool signature. So in the previous video I have mentioned that why the inclination angles are required. Basically to remove the rubbing or friction action between the workpiece and the cutting tool, you have to give the different inclination angle by the grinding process to different faces and surfaces of a single point cutting tool. So when you are giving those inclination, you have to enlist them in a proper way. It is nothing but a specification kind of things for a single point cutting tool. Whenever you are going to market and buy something like some electronics or electrical part, you go through the specification first. So in workshop, if you are going to perform a particular job, you have to select a proper cutting tool. So you have to learn the tool signature first, that what does the tool signature signifies. So it is the way to enlist the 6 different inclination angle and the nose radius in a particular manner. Different kinds of tool signatures are there, and in this video it is based on the ASA tool signature system. It is proposed by American Standard Association, and it is a machine reference system. What does it signify? That the 3 planes of reference and the coordinates are chosen based on the configuration axis of the machine tool, and you can say as long as the axis of the single point cutting tool is having a right angle with the axis of the workpiece, this kind of tool signature is valid. So you can see that here 6 different values are written, and you don't need to give the degree sign over there because it is predefined. So without giving the degree sign, it will obviously represent the value of the angles. And from the starts to end, you can see the angles are back rake angle, side rake angle, end relief angle, side relief angle, end cutting edge angle, side cutting edge angle, and the last one is nose radius. So it seems quite hectic to remember all those angles in a sequenced manner, and if you are not writing them in a sequenced manner, it is not valid. So it's very important to remember them in a sequenced manner. So let's see how you can remember. Here I have written a part that BS into 2 ES. You can read this line like this: BS 2 times ES N. So the 2 times ES will comes out like this. I have written 2 times ES. You have to remember that the B stands for back, A stands for side, and E stands for end. So BS 2 times ES N. First part BS is related to the rake part. You can see here back rake angle and side rake angle. So the first 2 angle will related to the rake part of the single point cutting tool. So BS will goes with the rake part of the cutting tool. Next it is written 2 times ES. Here I have written 2 ES here. You can see here that the third and fourth angle is end relief angle and side relief angle. So the first ES will stands for the end relief angle and the side relief angle, and the second ES is cutting related. You can see here that the third and fifth and sixth angle is end cutting edge angle and side cutting edge angle. So the fifth and sixth angle is cutting related angle. So the first ES is related to the relief part, and the second ES is related to the cutting part. Still, if you have a doubt that whether the relief part will comes first or the cutting part will comes first, I will share a story that suppose you have bring a goat or a chicken to your house, and after 10 or 15 days you are going to slaughter that particular animal to have lunch or dinner, whatever. So what you will do for the next further 10 or 15 days, you will feed that particular animal with proper food or material so that it can gain some weight. So what we are doing actually, you are giving relief to that. It is also relatable to the single point cutting tool, that you are giving the relief angle first, side relief and end relief. Okay, sorry, the end relief angle and the side relief angle. You are giving relief to them and then you are going to cut. So if you still have a confusion that whether relief will comes first or the cutting will comes first, you can remember those ways. So BS is related to the rake, it is back rake and side rake. 2 times ES will comes like 2 ES, and the first ES will represent 2 relief angle, end relief angle and the side relief angle. The second ES is related to the cutting part, that is the end cutting edge angle and the side cutting edge angle, and the last one is nose radius. I hope it's quite simple and useful to remember all those angles in ASA tool signature system. So I have mentioned in previous slide that the ASA tool signature is basically a machine reference system. So it follows the coordinates related to the machine. If you consider that this rectangular part is the machine, and suppose it is a lathe and this single point cutting tool is mounted here in the tool post, and this is a cylindrical job rotating like this, so it is having a turning operation in the lathe. So how the inclination angles are related to the those planes, as I have shaded here. The angles are being measured with respect to a plane and to a particular plane. So what is actually, you are measuring those angles to a plane, from a particular plane. So the machine reference system is the reference planes related to the measurement of the all inclination angles of that single point cutting tool. So you can see here you have 3 different axes. One is x axis, y axis and z axis, as the picture shown here, that it is the y axis, it is the x axis which is collinear with the major axis of the workpiece, and this is the z axis. So the planes between the z and y plane is shaded like yellow, and it is known as transverse plane, and the planes between the x and z axis is known as longitudinal plane, and it is known as pi x plane. The yellow plane is known as pi y plane, and this particular surface, that is the xy surface, is pi r, that is the reference plane. So these are the 3 different planes which are related to the measurement of the different angles of single point cutting tool. I hope you liked that video and keep subscribing.